Dear students, now come to the magnetic properties of transition elements. So the magnetic properties, when substances are subjected to external magnetic field, they show different types of response. This behavior is due to the presence or absence of unpaired electron in d orbitals. You may say d subshells. Substances have been categorized in three categories. Number first one is diamagnetic substances. Number second one is paramagnetic substances, and number third one is ferromagnetic substances. So number first one, if we come to the diamagnetic substances, these are the substances in which no unpaired electron are present in the orbitals. These are slightly repelled by magnet in magnetic field. So there are two conditions. The first condition is no unpaired electron. Second condition is slightly repelled by magnet and magnetic field. Now we take the example of copper and gold. Copper has 29 electrons. So its electronic configuration is argon. It has 18 electrons and 3d10s and 4s1. Now in 4s1 there is only one electron, and the 10 electrons are distributed in 5 orbitals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There is no unpaired electron. All the electrons are paired. So such type of substances are slightly repelled by magnet and magnetic field. The other one is paramagnetic substances. So paramagnetic substances, those substances which are attracted by magnetic field and which are attracted by magnet and magnetic field. Such type of substances are called paramagnetic substances. These substances have one or more unpaired electron, for example vanadium, titanium, scandium. So here we can see the first condition, that one or more unpaired substances should be present in d orbitals, and such type of substances are attracted by magnet and magnetic field. We take the example of scandium and vanadium. Scandium has 21 electron and vanadium has 23 electron. Scandium 21 electrons, so the electronic configuration of scandium is argon 18. There are 18 electrons in argon, and the two electrons will occupy themselves in 4s. Now only one is remained, that is d3d1. So here we can see that there is only one unpaired electron. So such type of substances are attracted by magnetic field. So the first one, copper, there were no unpaired electron, so such type of substance are diamagnetic. In the substances that have unpaired electron, such as scandium, vanadium. Vanadium has 3 unpaired electrons in its d orbital. So vanadium is also attracted by magnet and magnetic field. Now come to ferromagnetic substances. So these substances have more unpaired electrons and more strongly attracted by magnet. For example, iron. There are 4 unpaired electrons and 8 is strongly attracted by magnet. So this condition is called ferromagnetism, and the substance is called ferromagnetic substance. Okay. Now iron has 26 electrons. So the electronic configuration of iron is argon 18, 3d6 and 4s2. Now 2 electrons occupy the 4s2 position and the rest of 6 electrons distributed themselves in 3d orbitals like this: 1, 2, 3, 4, 5 and 6. So we have 4 unpaired electrons. 4 unpaired electron in d orbitals. So such type of substances are called ferromagnetic substance. This is also a paramagnetic, because here we can see 4 electrons, but for iron we can say that this is a ferromagnetic substance. Now come to important discussions. How can we find out the magnetic properties of transition elements? So by magnetic moment we can find the magnetic properties of a substances. There is a simple formula: mu is equal to n bracket 2 plus 2 bracket stop under root. This is a simple formula given for the measurement of magnetic properties. Here in such type of formula, the n is the number of unpaired electron. So here n is the number of unpaired electron. Put the number of unpaired electron, then find out the under root of that value. So it will give the value of magnetic substances. Its unit is Bohr magnetons. So its unit is Bohr magnetons. Actually, this magnet momentum can be measured by Gauss balance. There is an instrument used for such type of measurement. Okay, in other video we will discuss this balance in detail. So there is a great principle as a conclusion we take: greater the number of unpaired electrons, stronger will be the substances attracted by magnet and magnetic field. Now, they should be clear to you that paramagnetic behavior increases from left to right up to the middle due to the maximum of unpaired electron and then decreases to the minimum number of unpaired electron and then becomes 0 at zinc. So there is no magnetic property of zinc. An important question arises that, so if you take this, the scandium has, if you take this sentence, as we have already mentioned, that paramagnetic behavior increases from left to right up to middle due to the maximum number of unpaired electrons and then decreases to the minimum number of unpaired electrons, then becomes 0 at zinc. Look at the periodic table. Now look at this periodic table. You can easily find out the unpaired electrons of a substance of a metals. So look at the periodic table. Here you will see scandium 21 has 1 unpaired electron. Titanium 22 has 2 unpaired electron. Vanadium 23 has 3 unpaired electron. Chromium 24 has 5 unpaired electron. Manganese also has 5 unpaired electron. Iron 26 has 4 unpaired electron. Cobalt 27 has 3 unpaired electron. Nickel 28 has 2 unpaired electron. Copper 29 has 0 and zinc 30 has no unpaired electron. No unpaired electron. So there is no attraction or repulsion in zinc. Here we can see in copper a slightly repulsion by magnet and magnetic field as it has been mentioned here. From 1 to 5 manganese it increases, unpaired electron increases. Then from manganese to copper it decreases. So here we can see the paramagnetic properties also increases, while here the paramagnetic substances decreases up to copper and there is no repulsion or attraction of zinc and magnetic field. Now an important question arises that iron is ferromagnetic. Iron is ferromagnetic, while manganese is paramagnetic. So what is the cause? The cause is here clear that not only unpaired electron is responsible for the magnetic properties of transition elements. There are other properties also involved, like exchange of interaction. So we can say exchange of interaction. Exchange of interaction occur in quantum mechanical effect. Quantum mechanical effect. So both of these we will discuss in the next video. Exchange of interaction in quantum mechanical effect in the magnet moment. We will discuss these two in our next video. So there is another question. The question is, if E plus 2 and Fe plus 3. Now the question is, which one of Fe plus 2 or Fe plus 3, ferrous or ferric, is more attracted by magnet and magnetic field? In a natural position, its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s2. Okay. And ferrous position, when it carries a positive charge, so the electronic configuration becomes 24. In this case, 1, 2, 3, 4, we have 4 unpaired electron. In the ferric position, Fe plus 3, there is 23 electrons. So the electronic configuration of ferric should be 3d5 and 4s0. 3d5 and 4s0. Now draw the orbital of 3d. 1, 2, 3, 4 and 5. There are 5 orbitals. So there is no electron in 4s and there are 5 electrons in d orbital. 1, 2, 3, 4 and 5. Here we can see that there are 5 unpaired electrons. Now it is clear that Fe plus 3 is more attracted by magnetic, having 5 unpaired electrons. So Fe plus 3 having 5 unpaired electrons will be more strongly attracted by magnetic field. Dear students, thank you very much for your patience. Allah Hafiz.